Hi, Math Analysis. I'm sorry I couldn't be there today. I'm hoping that this video actually finds you and that you were able to watch this. I think most of what you're going to see in this presentation is going to be familiar with a few new things. So you can see we're doing the trig ratios, which I think you've probably seen probably in geometry. These here, sine, cosine, and tangent, look very familiar. These maybe not so much, but they're pretty easy to do, and we'll kind of talk about the relationship. They're all three related to the original three. So our objective today is to find the values of the 6 trigonometric functions in a right triangle. It's pretty easy, it's just fractions. So we love fractions, at least I love fractions. Okay, so when we do right triangle trigonometry, we are talking about basically ratios of sides of right triangles. And so if you look at sine of theta, theta is right here. You can see it. It's marked in the corner. If I find the sine of theta, it is basically the ratio of the side opposite. So this side is opposite. Whoops, I ran out of room there. This side is adjacent. Adjacent is the non-hypotenuse that actually makes or connects with the hypotenuse to make the angle. And of course, this is the hypotenuse. The hypotenuse is always the side opposite the right angle. So to find sine, we put the measure of the opposite side over the measure of the hypotenuse. We reduce, we rationalize denominators if we need to. For cosine, we put the adjacent length of the adjacent side over the length of the hypotenuse. And for the tangent, we put the opposite side over the adjacent side. Now, all we see here, you'll see a relationship that sine and cosecant, sine is opposite over hypotenuse and cosecant is hypotenuse over opposite. So sine and cosecant go together, cosine and secant go together. Secant's the reciprocal of cosine, and cotangent's the reciprocal of tangent. So that's pretty easy. In general, you just kind of have to memorize it. So on this next slide, I'll kind of talk about how I've memorized it. SOHCAHTOA, I'm sure you guys have seen that before. That means sine is opposite over hypotenuse. Sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. Whoops. And you can see cosine adjacent hypotenuse. And then tangent is opposite over adjacent. Okay. We just talked about how cosecant is the reciprocal of sine. And sine, I'm sorry, that was not right. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. Well, those two, tangent and cotangent, are pretty easy to remember. As long as you know tangent, cotangent is really easy to get. So if you notice, in each reciprocal pair, sine and cosecant go together, cosine and secant go together, tangent and cotangent go together. So when you're trying to decide what the reciprocal of sine and cosine are, each pair has a co-trig function in it. So sine would then have to go with cosecant, and cosine doesn't need a co, so it would be secant, and then tangent goes with cotangent. And that's kind of how I remember it. I remember this, and then I remember that relationship of each pair having a co of some sort. Let's talk about special right triangles. There are two special right triangles that we talk about, and they're called 30-60-90s and 45-45-90s. The reason why we call them that is because when you draw a 30-60-90 and a 45-45-90, that is what their angles are, and that really doesn't look like a 45-45-90, but you probably learned in geometry that you don't trust the picture, you trust the numbers. And then this one would be a 30, 60, and of course a 90. And that's why we call them that, because of their angle measures. So if we look at a 45-45-90, my right angle's here, I have a 45-degree angle here, and I have a 45-degree angle here, and I think we're going to use this one to find our 6 trig values. It really honestly doesn't matter at this point which 45-degree angle we come from. but I think this one's marked on your sheet, so that's the one we're going to do. So we know that all 45, 45, 90 have a side ratio of 1, 1, square root of 2. What that means is opposite the 45, one of the 45 degrees angles is 1. So 1 is opposite 45. Opposite of another 45 degree angle is the side 1, length of 1. And then opposite the 90 degree angle, or the hypotenuse, is a side length of the square root of 2. So what we do now is that we've assigned these. If it helps you, you can call this opposite, because remember we're working from this angle down here, opposite, and this one's adjacent. It makes the angle with the hypotenuse, and this is the hypotenuse. So when I go to make my ratios, I'm going to use this. So sine is opposite over hypotenuse, 1 over the square root of 2. I'm going to come back and adjust this in just a minute. Cosine is adjacent over hypotenuse, 1 over the square root of 2. Tangent is opposite over adjacent. This is 1. Oops, I forgot my 2. 1 over 1 is 1. Now, cosecant. Instead of trying to think of, okay, sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. In this case, because I already have sine up here, I can just flip 1 over the square root of 2, and I get square root of 2, square root of 2, because that's the reciprocal of cosine, and the reciprocal of tangent, which is 1, is just 1. So easy, easy. Now, one of the rules we have in mathematics is it's kind of like having a 0 on the bottom. We're not allowed to have square roots on the bottom. So what we do to get rid of those is we multiply by a fraction made up of those 2 square roots. So I end up with square root of 2. So I'm taking this square root of 2 and I'm making a fraction out of it, square root of 2 over the square root of 2. Well, square root of 2 over square root of 2 is equal to 1. So that doesn't change the value of the number, it just makes it look different. So 1 times the square root of 2 is the square root of 2. The square root of 2 times the square root of 2 is the square root of 4, which we know we can turn into 2. And so 1 over the square root of 2 actually equals the square root of 2 over 2. That's how we should present that answer. The reason why I waited to do this till last was because it's easier to find the reciprocal of this for cosecant and secant than it is to find the reciprocal of that. This is a little bit more work. Okay? Let's move on to a 30, 60, 90. Now we can do the sine, cosine, and tangent, and the secant, cosecant, and cotangent of 30 degree angle, but we can also do it of the 60 degree angle. So the deal is, it just depends on which angle you're working with. So since it says 30 degrees, cosine, sine of 30 degrees, we're doing this angle right here. And so, cosine, I always like to start with sine. Oh, I forgot to talk about the ratio. So the ratio of a 30, 60, 90, the side ratio is 1 square root of 3, 2. We always start with the shortest and go to the longest side when we talk about these ratios, because we start with our smallest angle to our longest, our biggest angle. And so that way they have a good correlation. The smallest side will be opposite the smallest angle, so that's why we have 1 here. The medium-sized angle is 60, and so it'll be opposite the medium-sized side length, which is the square root of 3. And the hypotenuse is 2. And so you can see it's all set up for us down there. So let's start with sine, because I like to start with sine. Sine is opposite over hypotenuse, which is 1/2. Cosine is adjacent over hypotenuse. Please excuse my son if you can hear him in the background. He thinks he's bored. And then the tangent is opposite over adjacent, or 1 over the square root of 3. I will rationalize this momentarily. This one doesn't need to be rationalized because the square root's on the top. But when I come over here to flip it, it's going to become 2 over the square root of 3, which I do have to rationalize. So it becomes 2 square roots of 3 over the square root of 9, which equals 2 square roots of 3 over 3. Okay, so this reciprocal of 1/2 is 2, And then this one is just going to become the square root of 3 over 1, or just the square root of 3. Now that I've done that, I'm going to rationalize this one. So I'm going to multiply by the square root of 3 over the square root of 3. Square root of 3 over the square root of 9 equals the square root of 3 over 3. Okay. So we're not going to use calculators right away, except for maybe some simple calculations, but just so you know, if you do not have a calculator that computes trigonometric functions, most scientific should do this. The graphings will do this. You might want to get one because you're probably going to have to use it at home. If you need one in class, you can use one of mine as long as I have plenty of them. If you are using a graphing calculator, make sure it is in degree mode when we're evaluating sine and cosine and tangent. Make sure your answers are logical. If they aren't, you might be in the wrong mode. Scientific calculators can also be in the wrong mode. Okay, so let's refresh ourselves about the Pythagorean theorem. This is helpful sometimes when we do what's called solving right triangles, which is what we're going to do here in a moment. If you recall the formula a squared plus b squared equals c squared, that means if we have a right triangle, your legs are a and b because they're the short side and they equal to c, and then we plug it in and so forth. I'm not going to spend a lot of time on that because I think you guys have done this a million times. Okay, I got my slides out of order, so we'll kind of do this one and then I'll come back and go to the last one. So, solving a right triangle. What I'm basically trying to do when I'm solving a right triangle is find all the missing parts. So, triangles have two kinds of parts. They have angles and they have sides. So, we don't know what this angle is yet. We will momentarily. We don't know what this side is, the hypotenuse, or what the measure of this leg is. Well, we all remember that all the angles in a triangle sum to be 180 degrees. So if I take 180 and I subtract this right angle here, and I subtracted this 53 degrees here, I should get what's left in this angle right here. I'm going to call this angle X, so I'll have some way to label it. So 180 minus 90 is 90, minus 53 looks like it's 37 degrees, so the measure of angle X is 37 degrees. Now we're going to find A and B. The way we're going to do that is we're going to have to first start with a trig setup. So I'm going to use trying to decide what I want to do here. So I think I'm going to do the cosine. No, I'm not. I will do the tangent of 53 degrees. And then we're going to do opposite over adjacent, which equals 8 over b. Okay. You want to use your calculator, make sure it's in degrees. We're not going to do a whole lot with this, but this is one thing we're going to do. We're going to approximate this to a couple of decimal places. So when I plug this in, 53 tangent of, I get that this equals 1.327 equals 8 over b. I want to get b in the numerator, so I think I'm going to multiply both sides by b. It gives me 1.327 equals, oops, I forgot the b, equals 8. Now I'm going to divide by 1.327. So b equals 8 divided by 1.327, approximately 6.029. And so I get that the length of b is 6.029, and I can use the Pythagorean theorem to get the hypotenuse. 8 squared plus 6.029 squared, I don't know why I put that parenthesis there, equals c squared. So let me square that and then add 64 to it. And then I'll square root that momentarily. And I got approximately 10.017. Okay, essentially what I've done here is I've solved the right triangle because I found all the missing parts. Okay, let's do this one. This one's a little tricky. We're basically solving the sides for a right triangle on this one. So if you think about, let's put theta here, the sine of theta. I don't even need to know the angle to do this. But I do know that sine is opposite over hypotenuse. So when that's the case, that means 3 is the side opposite theta, and 7 is the hypotenuse. And so I need to use the Pythagorean theorem to get this third side. So 3 squared plus b squared equals 7 squared, or 9 plus b squared equals 49. In this case, we are not going to do decimals. We are going to do square roots. And so what's going to happen is I'm going to subtract 9. I'm going to get b squared equals 40. Square root both sides. And then I got to think about breaking down 40. I'm going to take this, or the square root of 40, up to the top of my thing here, my slide. I'm going to break it down. 2 and 20, 2 and 10, 2 and 5. And so what I have is the square root of 2 times 2 times 2 times 5. I'm looking for a pair of 2's to pull out, so it becomes 2 square roots of 10. So I pull out one number for each pair I find, and then I leave and multiply what's left underneath. Those of you that I have in college algebra, if you have some classmates that need a little help with this, since we've done this already this year, I would appreciate it if you could help them out. Okay, I'm going to write this down here. I'm going to label this side 2 square roots of 10. And then I'm going to come over here. I know that the sine of theta is 3/7. That was given. Now I need to find the cosine of theta, the tangent of theta, the cosecant of theta, the secant of theta, and the cotangent of theta. Well, cosine is, remember here we are, this is adjacent, this is opposite, this is hypotenuse. Cosine is adjacent over hypotenuse, so 2 square roots of 10 over 7. Tangent is opposite over adjacent, 3 over 2 square roots of 10. I will get rid of that in a minute. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Oh, we're going to have to rationalize that one. And cotangent is reciprocal of tangent. Okay, so here's what we're going to do. We're going to rationalize this guy by multiplying not by the 2, just the square root of 10 over 10. That's all I need to do. And so I get 3 square roots of 10 over 2 times the square root of 100, because 10 times 10 is 100. So 3 square roots of 10 over 2 times 10, 3 square roots of 10 over 20. Okay, so this is what tangent is. Secant is the same idea, square root of 10 over the square root of 10. So I get 7 square roots of 10 over 2 times the square root of 100 equals 7 square roots of 10 over 2 times 10, which is 7 square roots of 10 over 20. And there's your answer there. And what you've done is you've evaluated the remaining trigonometric functions. Okay, you have an assignment that the substitute will give you. I think it's Miss David, if that's what I remember from seeing my email. Hi, Miss David. Thanks for subbing for me today. If you have any questions, bring them to class tomorrow. I plan on being back. This is Mrs. Lauer signing off.